Hi, welcome to another lecture on technical mathematics. In this video, we will begin a new section, that is calculus. We will focus on the topic limit of a function. So let's get started. At first, let's have a look at the definition of limit of a function. Suppose we have a function f of x defined on the set of real numbers capital R, and if we are plotting the curve of f of x on the xy plane, suppose we are getting a curve something like this, then a limit exists for the function f of x at the point x equal to a, provided f of x satisfies this condition, that is limit x tends to a minus f of x is equal to limit x tends to a plus f of x equal to L. That is, when we approach the point x equal to a from the left side and right side, the value of f of x should converge to capital L. Okay, so when we approach x equal to a from left side, we may see that f of x value tends to capital L. Similarly, when we approach the point x equal to a from right side, we can see that f of x tends to the value capital L. So if this condition exists, we may say that limit exists for the function f of x, and we will represent it like this: limit x tends to a f of x is equal to L. Okay, now let's see another scenario. Here we have a function f of x which is discontinuous. Okay, so at the point a, the function is getting discontinuous. Now when you approach the point x equal to a from left side, you can see that the value of f of x tends to the value L1. Okay, so limit x tends to a minus f of x is equal to L1. Now when we approach the point x equal to a from the right side, we can see that f of x tends to a value which is equal to L2. That is, limit x tends to a plus f of x is equal to L2. So these two values are not equal. Therefore, limit does not exist for f of x at the point x equal to a. So for a function f of x to have a limit at a point x equal to a, it has to satisfy the condition that limit x tends to a minus f of x should be equal to limit x tends to a plus f of x. Okay, now let's have a look at the methods to find limit of a function at a given point. We have three methods to find limit of a function at a given point. The first method is direct substitution, the second method is simplify and substitute, and the third method is LHospitals Rule. At first, we will have a look at direct substitution method. We will discuss this method using an example. Suppose we have a function f of x equal to sin x by x, and if we are asked to calculate limit of this function at x equal to 0. Okay, using direct substitution, what we do is we will substitute the value of x as 0. Okay, so when you substitute x equal to 0, what we get is sin 0 divided by 0. Okay, so we know that sin 0 is 0, so result is 0 by 0. Okay, so this is an indeterminate form. So the value of limit, we are getting it as indeterminate. It doesn't mean that limit does not exist at the point x equal to 0. To find out the limit of this function at x equal to 0, we will be using simplify and substitute method, or otherwise LHospitals Rule. So using direct substitution, we may not be able to calculate limit of a function at a given point. Usually it will result in indeterminate forms like 0 by 0 or infinity by infinity. Okay, now let's have a look at simplify and substitute method. If we have a function something like this, x minus 1 divided by x square minus 1 square, and we are asked to calculate limit of this function at the point x equal to 1. If we go for direct substitution, it will result in the value 0 by 0. Okay, you can see that when we substitute x equal to 1 here, we will get 1 minus 1 as the numerator, and when you substitute x equal to 1 in the denominator, we will be getting denominator as 1 square minus 1 square. So both numerator and denominator turns out to be 0, 0. Okay, so the result what we are getting is 0 by 0, which is an indeterminate form. Now we are unable to find out the limit at x equal to 1. So let's use simplification and substitution method. Okay, so you can write x square minus 1 square as x minus 1 into x plus 1. Okay, if we expand the denominator term like this, you can see that we can cancel this x minus 1 with this one, and we can simplify the expression as 1 by x plus 1. Okay, so first we are simplifying the given expression, and then if we substitute x equal to 1 in this expression, what we get is 1 divided by 1 plus 1, which is equal to 1 by 2. So the value of the limit at the point x equal to 1 is 1 by 2. Okay, so this way we can find out the limit of the given function at a point using simplification and substitution method. Okay. Now let's have a look at LHospitals rule, the third method to find out limit of a given function. Suppose we have a function defined as f of x by g of x, and if we are asked to calculate the value of the limit of this function at the point x equal to a, when we go for direct substitution, what we do is we will substitute x equal to a, so we will get the ratio as f of a by g of a. And if this turns out to be an indeterminate form like 0 by 0 or infinity by infinity, what we can do is, the LHospitals rule says that we have to differentiate both numerator polynomial and denominator polynomial and then substitute the value of x to a. So we will be getting the ratio f dash of a by g dash of a, and if we are again getting 0 by 0 or infinity by infinity, an indeterminate form, then go for the second derivative and then do the substitution and find out the limit value. Okay, so let's see an example. Suppose we are asked to find out limit of a function sin x by x at the point x equal to 0. If we go for direct substitution, we can see that what we get is sin 0 by 0, which is nothing but 0 by 0. Okay, now we can use LHospitals rule here to find out the limit value. LHospitals rule says that we have to differentiate both the functions. Okay, so when you differentiate sin x, we will get cos x, and when you differentiate denominator polynomial x, we will get 1. Okay, now substitute x equal to 0, what we get is cos 0 by 1, which is nothing but 1 by 1, and finally we will get the result as 1. Okay, so we are getting the limit value of this function at the point x equal to 0 as 1. Okay, so using LHospitals rule, we are finding out the limit of the function. Let's see another example. Limit x tends to 0, x square divided by sin square x. So we are asked to calculate the limit of the function x square divided by sin square x at the point x equal to 0. If we go for direct substitution, what we get is 0 square divided by sin 0 square. So we will get it as 0 divided by 0. So we are getting an indeterminate form. So let's apply LHospitals rule. LHospitals rule says that we have to differentiate both numerator and denominator. So when you differentiate numerator, that is x square, we will get 2x, and when you differentiate the denominator, we get 2 into sin x into cos x. So here 2 and 2 can be cancelled. So resulting expression is x divided by sin x into cos x. Now substitute x equal to 0 in this expression. What we get is, we will get 0 in the numerator divided by, here we will substitute 0. So what you get is sin 0 into cos 0. So sin 0 is 0, therefore 0 into cos 0, that is 1. 0 into 1, we will get denominator also as 0. So again we are getting indeterminate form, that is 0 by 0. So LHospitals rule says that if we are getting indeterminate form, we have to differentiate once again. So let's differentiate numerator, that is x. So when you differentiate x, we will get 1. When you differentiate sin x into cos x, we will get sin x into d by dx of cos x, that is minus sin x, plus cos x into d by dx of sin x, that is cos x. So we will get the expression as 1 divided by minus sin square x plus cos square x. Now substitute x equal to 0, what you get is 1 divided by sin 0 square. So that will be 0 plus cos 0 square. Cos 0 is 1, so 1 square, that is 1. So we will get 1 divided by 0 plus 1, that is 1. So we will get the final answer as 1. Now let's see few exam questions. Problem number 1. If limit x tends to 2, x raised to n minus 2 raised to n divided by x square minus 4 is equal to 20 and n is a positive integer, then n is. We are asked to calculate the value of n. It is given that n is a positive integer and n has to satisfy this condition. Okay, so here the expression is that of a limit. Okay, it is saying that limit x tends to 2, x raised to n minus 2 raised to n divided by x square minus 4 is equal to 20. Okay, so you may pause the video and try to solve this, try to find out the right answer. Okay, now coming to the solution, here at first we may go for direct substitution. When you do direct substitution, what you get is 2 raised to n minus 2 raised to n divided by 2 raised to 2 minus 4. So this is 0 divided by 0. We are getting an indeterminate form. Okay, so let's go for LHospitals rule. We will differentiate numerator term and denominator term. So we will get it as limit x tends to 2 n into x raised to n minus 1 minus 0 divided by 2x minus 0. Okay, so we are getting it as limit x tends to 2 n into x raised to n minus 1 divided by 2x. Okay, now let's substitute x equal to 2 in this expression. What we get is n into 2 raised to n minus 1 divided by 2 into 2, that will be 4. Okay, so we are getting the limit value as n into 2 raised to n minus 1 divided by 4, and in the question it is given that the value of the limit is 20. So let's equate this expression to 20. So n into 2 raised to n minus 1 divided by 4 must be equal to 20. So let's take this 4 to the right hand side. What you get is n into 2 raised to n minus 1 is equal to 80. Okay, now let's look at the options. The first option says n value equal to 3. So when you substitute n equal to 3 here, what you get is 3 into 2 raised to 3 minus 1, that is 2. So we get 3 into 2 raised to 2 here. So that is equal to 3 into 4. What is that value? It is 12. Okay, now if you substitute n equal to 5, okay, what you get is 5 into 2 raised to 5 minus 1. So that is 2 raised to 4. So we are getting it as 5 into 2 raised to 4, that is 5 into 16. Okay, so when you calculate that, you will get it as 80. 5 into 16, it's equal to 80. So n equal to 5 is the one which satisfies this expression. Okay, when n is equal to 5, we will get the value as 80. So the right answer is given by option B, that is 5. N value should be 5. Okay, now let's see another problem. Limit x tends to 2, x into root x minus 2 into root 2 divided by x minus 2 is. So we are asked to calculate the limit value of the function at the point x equal to 2. So let's go for direct substitution first. If you do direct substitution, what you get is 2 into root 2 minus 2 into root 2 divided by 2 minus 2. So what we get is 0 by 0, which is an indeterminate form. Okay, so let's apply LHospitals rule here. Differentiate numerator term and denominator term. So if you differentiate numerator term, what you get is, so here expression modifies as limit x tends to 2 x into d by dx of root x plus root x into d by dx of x. That will be the differentiated version of the first term in the numerator. Then here we have a constant, so we will have minus 0 here, divided by, when you differentiate denominator term, what you get is 1 minus 0, 1 minus 0. Okay, so this is equal to limit x tends to 2 x into d by dx of root x. It is 1 by 2 root x plus root x into d by dx of x, that is 1. So root x into 1 divided by 1. Okay, so now let's apply substitution. Substitute x equal to 2 in this expression. So what we get is 2 into 1 by 2 root 2 plus root 2. Okay, so this 2 and this 2 will be getting cancelled. So what we are getting is 1 by root 2 plus root 2. Okay, so when you simplify that, what you get is, okay, when you multiply this root 2 with this root 2, we will get 2. So we will get 1 plus 2 divided by root 2, that is 3 by root 2. Okay, and that is given by option B here. So option B is the right answer. Okay, so with this we are coming to end of lecture 19. In lecture 20 we will continue with limits. We will discuss continuity of a function at a given point. So see you in lecture 20. Goodbye.